At the end of this video, you will be able to state the basic properties of limits. There are a lot of basic properties of limits, but I list a few of them that are important to us. The first one is, if k is a constant real number, then limit x approaches a k, you get back k. Look at the example on the right. Limit x approaches 3, 5, so we get back 5. Second, if c is a constant, then limit x approaches a, the constant c multiply with function fx. What we can do is, you can move the c in front and find the limit x approaches a fx. For example, you have limit x approaches 3, 5x. So we move 5 here, and then we can evaluate the limit, we get 15. The third properties is, limit x approaches a, function fx plus or minus function gx. Then we can change into limit x approaches a fx plus or minus limit x approaches a gx. For example, we have here is limit x approaches negative 1 for the function x to the power of 4 minus 4x cubed plus 5. So we can apply the third properties where we can split each term. So what we have here is limit x approaches negative 1 x to the power of 4 minus the constant 4 we can bring in front, so we get 4 limit x approaches negative 1 x cubed plus limit x approaches negative 1 5. So evaluate the value by substituting x equal to negative 1, and from the first properties just now, limit x approaches negative 1 constant 5, then we get back 5. So calculate, the answer is 10. The fourth properties is limit x approaches a, function fx multiply with gx. Then we can split into limit x approaches a fx times limit x approaches a gx. For example, limit x approaches negative 2 for the function 10x squared multiply with x minus 1. So we can split into limit x approaches negative 2, 10x squared, multiply with limit x approaches negative 2 for the function x minus 1. Then we substitute the value of x and we get negative 120. The next properties is limit x approaches a fx over gx can be changed into limit x approaches a fx over limit x approaches a gx, and note that limit x approaches a gx cannot equal to 0. If the denominator is 0, then the limit cannot be evaluated. For example, limit x approaches 3, 5 over x, we can change into limit x approaches 3, 5 over limit x approaches 3x. Then substitute the value of x, we got 5 over 3. The next properties is limit x approaches a fx to the power of n. So we can change like this. Look at the example. We want to evaluate the limit x approaches 2 for the function 3x plus 1 to the power of 5. So, we just put the power outside here and evaluate the limit x approaches to 3x plus 1. Substitute x with 2 and we got 16807. Next, limit x approaches a and root of function fx. So we can write like this. For example, limit x approaches 1, for the cube root of 2x squared plus 6. So first of all, we evaluate the limit x approaches 1 for the function 2x squared plus 6. Substitute the value and we got the answer is 2. Computation of limits. Actually, to evaluate the limit, we just use direct substitution method. The limit of a certain function may be evaluated by substituting x equal to a into fx. Example 3. Evaluate the following limits. Question A. Limit x approaches to negative 10. So we want to evaluate the limit for the constant function, and we know that from the previous properties that we have learned, we will get back negative 10. Question B. Limit x approaches 2 for the function negative 3 ln x. So what we can do is just substitute x with 2 and we get negative 3 ln 2. Question C. Limit x approaches 3 for the function 4 plus x squared. We use direct substitution method where we just substitute x with 3 and calculate, we get 13. Next example. Evaluate the limit x approaches 4 for the function 5x times x cubed. So we substitute x with 4 and we got 1280. Question E. Evaluate the limit x approaches 8 square root x minus 2. We substitute x with 8. So we got 6. This is question F. Okay, direct substitution where you substitute x with negative 1 and you got 0. G. And this is the solution of H. Example 4. If the limit x approaches 4, fx minus 5 over x minus 2 equal to 1, find the limit x approaches 4 fx. To solve this question, you need to know how to use the properties of limit. So first of all, we substitute x with 4 and then 4 minus 2 here, we got 2. We move to the right side. And by using the properties of limit also, we split the limit x approaches 4 fx minus 5 and we got limit x approaches 4 fx minus limit x approaches 4 5. From the properties of limit, this value is 5. Then solve, we have limit x approaches 4 fx equal to 7. Hopefully you already know the basic properties of limit, and remember, limit is to see the behavior of the fx of the graph of the function as x become closer and closer to a.